Thank you for joining us for Women in Drones Coffee Connection with Desi and Kim. Today, our spotlight speaker is Jon McBride with RMUS. Jon has been involved in developing UAV systems for nearly 20 years. He has implemented dozens of UAV programs for municipalities. He has a large social media following due to his vast knowledge of thermal UAV systems and pioneering work in the UAVs. Jon served 5 years in the U.S. Marine Corps studying microelectronics. He's one of the founders for RMUS, and he is a level 1 thermographer. We are so happy to have you here, Jon. Thank you for joining us. I would like to kind of get started already. So as you already know, Jon McBride is our spotlight speaker. He's with RMUS, and I know a lot of you already know who he is, and so that's why you've joined us today. But I wanted to share a little bit more. I mean, you know about his social media. He's got a large following on his social media because of his knowledge that he has in the thermal systems. And so I know you're excited to hear from him, and he will be listening to what he's going to share about the thermal industry. So let's go ahead and just bump him right over and open this up. I'm going to make you spotlight, okay?
Excellent. Okay, yeah, I'm Jon McBride with RMUS. Again, I've been doing drone stuff for almost 20 years. I mean, it's been almost 20 years of doing what we would consider drone stuff. It's kind of challenging in today to really start when that was, because most people are like, hey, I bought my first drone. That's when I got into it. But when it came down to where I classify is just creating things that were not radio control, enjoying the hobby, flying around, having a good time with that, and not making them radio control, but making them actually have purpose, have a job, flight controllers that stabilize, they help you fly. So we're taking the hobby of RC and then moving it into autonomous type flight, you know, and that started for me about 20 years ago. The one thing that was really awesome about this show is coming on and actually hanging out with Kim and Desi, because I have my own way that I met them in the very first time and kind of understood about these people out there that actually, as Desi mentioned, have been watching me on the internet, watching videos that we've been putting out, gaining, you know, helping spread knowledge overall in the industry. And when I first met both Desi and Kim, it was Desi was kind of that, oh my God, it's Jon McBride. Oh my God, it's Jon McBride. And I'm like, hey, it's just Jon McBride. I mean, it's not any big deal. And Kim, on the other hand, was like, hey, I got a bunch of questions, business questions. He was like straightforward, like, bam, I just have business questions for you. And I was like, okay, some things to think about as you're culturing your business and making it awesome, in which obviously doing what we're doing today is obviously shown the drive and passion. And this is where it all comes from. It's just that drive and passion to understand. And as we get into basically thermal stuff, super complicated. It's not easy just to go out and say, hey, I bought a thermal camera and I want to do stuff with it. So and if we don't really try to understand the theories of it, the science behind it, what we're seeing on the screen, why it shows up the way it is, what others have actually done have done a lot of back end work to present something to everybody on how they did a certain workflow or something. There's a lot of work that goes into the thermal side. So we're going to talk about it today, kind of understand a little bit about it, understand why it becomes a pain in the butt, and additionally where it can really help and excel us. So I'm kind of a more informal, Desi and Kim, you guys can jump in at any time and just be like, hey, we have a question or whatever. And feel free to again, ask any questions, because like I said, I like the more informal feel and just kind of going through. So if you see something that might be, you want to address or talk about, I'm happy to discuss it and figure that out. And again, I have plenty of time today. Desi thinks I don't have time, but no, I have time. It's fine. We're all here to hang out. I'll stay here as long as we need to. So, right? We're good with that? So anyway, I'm kind of broadcasting a little bit differently on how we normally do it instead of sharing screen. So I'm hoping that everybody can see basically the different, we go into a cool effect when it happens, but when we jump around and just see screen sharing, okay, we're just making sure that works. I have my audio guy and video guy, Jace, that always helps me make sure I look good on camera and we do good things and I talk well. So anyway, as we go into basically thermal imaging, I'm just going to open up an image right now that basically has a thermal image. And I'm hoping you can see that as far as what you're capable of viewing. And this is just a normal, what we would expect out of a thermal image is that we've got some hot and cold spaces. So we've got some hot space here, we've got some cold space here, and we have an amount of temperature that's being shown somewhere between 51 degrees down here on the bottom, 102 degrees up here on the top. And we can manipulate this image just a little bit by changing what we call color palettes. And when we change these color palettes, this is just displaying to us a different way to look at it. And with some color palettes, we can see things that we can't see in other color palettes really well. So this is kind of a way around basically understanding that thermal imaging itself, we're not changing the way the color looks. What we're changing is how the data is being represented to us, if that's the best way to explain it. How is it represented to us to give us a level of color to highlight certain things? So we're very familiar with how this looks and what it is. Some people may not be at all, but when we then take this image and then create a what we call adding a actual temperature, I'm gonna put a spot meter on here and just stick it somewhere, and it shows up over on this other side as that spot being approximately 105 degrees. But when we do this, we have to be very careful because there's a lot of information here that the camera absolutely has to have in order for us to get that information correct. And from the sky, this becomes and tends to be a little bit bigger of a problem than being right up next to the transformer as we're observing here. So when we're spaced away, we have a lot of environment in between, we can make a lot of mistakes, you know. And so this is just the general knowledge that people see. But when we go into actually understanding the theories behind this, and let me see if I can pull up my little slide deck here. Oh, wrong image. Sorry, I'm jumping around all over the place here. Let's come back into theory here. Let me find my output here. So when we come into the theories of it, what we have a lot of the time is we're looking into thermal, the actual spectrum. And we call it thermal because we expect it to be basically heat. How does the heat work?
So are we supposed to be seeing your screen right now?
Oh, let me jump back to me. Sorry. No, you should be seeing me. Can you see me?
Oh, we see you. Yep.
Okay.
We don't see your screen.
As soon as I find my image here. Sorry, I apologize.
Gotcha.
Sorry. No, you're good. This is the reason why you have to jump in, because sometimes I'm a dummy and forget to push a button. So you're perfectly fine. Okay, let's jump over to the computer. We'll take a look at basically the spectrum. So without getting too way in depth into this, the electromagnetic spectrum is what we're looking at. And we have a wavelength of light that basically comes in. This light is visible in one section, and we can see this light as normal light. But when we get into thermal, what we're looking at is basically the energy that's being transmitted from something. Nothing more than that. That energy can be measured to a certain point. We call this thermal or temperature sensing. There's radiometric imagery that's very important to understand here. and then there's non-radiometric imagery. So depending on the sensor itself, depending on the range that it can kind of hang out and find and see this thermal spectrum, shortwave, middle wave, and long wave infrared. And a lot of the stuff we use is in the long wave. All of the cameras that I was just showing, we usually are in the long wave space. What we have is, again, thermal energy that's being broadcasted, hitting the camera. When it hits the camera, we are then showing or creating false imagery or false color to then represent that. And we run into basically the difficulty here. I'll jump back over to me. Run into the difficulty here of when people think thermal, they watch what happens on the TV or movie screen. And on the movie screen, they think, well, this is weird because they can see me inside my house because it's thermal. But that's not true. You can't see through the glass or the cup. You can't see through windows. You can't see how many occupants you have in a car. So on the public safety side of things, we run into basically guys wanting to buy this stuff. And a lot of the use cases here, I want to see when the car was parked. I want to see if he threw his weapon out because he fired it twice and threw it out in the environment. We might be able to find that. Possible, but very difficult to make that work with thermal energy. We move on to the public safety as well, looking for people. And we're going to watch a video here shortly of looking at somebody and finding that it's very complicated when you're looking at these thermal differences that do not exist. And where is the person when they're in a big field, which you would expect them to show up. Other things that we can talk about in the public safety space is basically finding somebody, but not necessarily finding them in a nice wooded area, but how you can find somebody in the challenges that you might find in them in an urban area, because the thermal camera can really mess with us looking at that. So I'm going to jump back over to my broadcasted feed here. It's probably the black screen until I turn my computer on. Oh, here's that volcano thing I was showing you, Desi. Let's see. Okay, I'm totally jumping around all over the place. I apologize. We're going to jump back over to here.
No worries.
Yeah. You guys are probably like, what the?
Right? It's all good information.
It's trying to get the
really cool. How'd you do that?
Oh, well, I can't tell you that. It's like that.
Cool.
That's secret sauce there, Kim Playas.
I guess so.
Yeah, I can't tell you. I don't even know how I did it. I have to ask Jace how he did it. Okay, so just this video, and this is coming back to basically understanding a little bit of thermal. Sorry, I'm going to close all these screens I have here. I was looking for my file. Come on. Let me play back this video, and this is observing basically the cows, if you will. If this will let me do it here. Okay. Technical difficulty. Please hold. Let me make sure I got this right. This is a little bit different. I apologize. It's, Desi already said it was very informal, so it's okay.
Very informal. You're sharing information. No worries. This is,
okay.
We're real. We're all real.
Here we go. Jumping over to the thermal video. I'm trying to
Bring
show
it
you.
on.
Okay, here we go. Okay, bunch of cows. We have the back end side. We're going to use this as two different things to observe here and on what we're watching. So one is that when we're looking for somebody, there's a somebody. Can you see him back in the left corner? Can we see him? He's like right here walking, and he mixes in. Yep, he mixes in with the back end, and you can't see much. We have a lot of energy coming from the cows. So we keep continuing with this video. If you didn't notice that he was actually in video going, you probably wouldn't notice that there was even people back there. We were asked basically to see if we could do temperature sensing on a cow. How well would a flying thermal camera take a temperature from a cow's butt or head or on their side?
Does that barn actually have an upstairs?
It does.
I never seen that before.
Yeah. And this is a huge farm, basically that does that. In spotting, when we do spotting and stuff like that, as we move on to the cow section from there, I was just showing you that it can be complicated to see things in the background because there's a lot of energy. And in this video, let's just hold right there, pause right here. The other thing with thermal is we don't have a lot of resolution. So that's the other problem. In order to get a lot of resolution, the cameras become very expensive. And because they are expensive in general, it's really hard to establish exactly what's on the screen when you're flying around. So you see a couple of hot spots here, and they do exist there. And trying to know exactly what are they a cow? Are they a horse? Are they a deer? That's one of the more complicated things we run into with thermal, is getting enough resolution with the imager to establish. Is it a deer or is it a cow, Desi? What do you
I'm
think?
going to go with a deer.
Why would you think it's a deer?
Because I was hoping.
Yeah,
It's the
the ears
ears.
pop up. Yeah, it's those ears, Vic.
Oh, there we go. Thank you, Vic.
Yeah,
You rescued
So
me.
those ears definitely popping up, and you can see a little bit thinner, and then we can see them trotting across basically the cornfield here. So they don't leave, and what a lot of people think is they don't leave a trail of heat. That's really hard to discern that. In this portion of the video, I have a fox that I was tracking. As I was flying around, you can see the fox. And if you didn't, let me pause it one more time, bam. If you were just to look at a single image here, can you see the fox? Can anyone see the fox? Did anyone even know it's a fox?
I would not have known it's a
Fox.
fox, but I see him. I also see a bunny up in the upper left-hand corner, right? No.
Yep, either a bunny or a squirrel. It could be one of the two. Yep. So as we keep watching and how the background will mix in with that thing, he is watching the drone. Actually, it's nighttime, and he's watching it right now. He's seeing it. He's investigating, like, what is it? But until he starts moving, I don't know. I can't tell, like I said, I couldn't obviously hear from this angle. I could see him really well. But from any other angles, he might be a little bit difficult. So we constantly have to move in thermal too, to get the best imagery of something.
John, what kind of ground is that that's retaining that heat?
So it's a game trail, and we're just looking at grass, basically, with a small walking game trail. And that's it. It's just tall grass. And so you would think that it's retaining, but this is a really good observation in either retaining heat, or is it the emissivity of the items that are there? And I'll give you a use case of this, kind of show you that. So let's watch the rest of this. Do a little bit further here. Chase him down for just a few more minutes. And what I was doing here was actually trying to find pigs. I was hunting pigs, but it was an interesting use case of we're trying to find pigs out in the middle of nowhere. So at the end of this video, basically, yeah, we were asked to try and get temperature from the air, and this is just will it work or will it not? And the funny thing, or the interesting thing, I wouldn't say funny, but the interesting thing in thermal here is that what I see is fur patterns on the cows. The patterns of what their fur looks like, not that they're just hot. Does that make sense to everybody? So this could be complicated, because would that mean that they are this temperature right here? Or are they this temperature right here? So we found, as we keep moving along, so here again, I can see patterns from the fur, not just that they're just hot. So it's hard to go and say, well, where do I get a correct temperature on the side of their fur if their emissivity of brown fur versus the emissivity of white fur is different? How do I get that temperature? Well, the best way we could find it was let me get a little bit further, shooting them right in the butt. Nowhere else you could really get a spot to get a good temperature. So in this use case, it didn't really work well to fly around trying to get temperatures of cows. And that's basically what I'm telling you. So if you call me and ask me, John, I want to buy a thermal camera so I can check temperatures of cows, that's a bad idea. We've already done that. It doesn't work very well. Can you find the cows? Absolutely. You can find the cows, but trying to get a really good accurate temperature from that far away in a distance, not very obtainable, very difficult to do that. Any questions there on that?
So I saw a few questions popping in, and while we have people maybe unmic to ask, I have a few questions myself.
Absolutely.
So can you explain a little bit deeper as far as emissivity?
Oh, absolutely. So emissivity itself, let me see if I can get back over here to this Zoom, because I can't see the check the question. So emissivity is the amount of energy in which we are pushing out for people to observe, for the camera to observe. It's a coefficient, it's a formula, it's an amount of energy. We rate this up against something called a black box. A black box is a perfect radiation of energy, and we give this a number. We call it 1.00. The highest amount of, it's not reflecting any of its own energy. It's not absorbing any energy. It's actually radiating energy from itself. That we give it a number of 1.0. Well, when we come back to this image, I'll open FLIR Tools again. Share my screen and make sure that's working. Is that working there?
Yes, it is.
Okay. So when I change emissivity, and that's this number over here on the right, this does change how it impacts how it's calculated to give me a temperature in a spot. So if let me just give an example here. We'll put the spot meter back on here. And now this spot right here, I've told it, measure that area, and it's 104.7 degrees. If I change the emissivity, which is the number in which I believe that this product is emitting enough energy from it, is around 0.95. If I bring this number lower to 0.80, well, what does that mean? What am I doing? Well, what I'm doing is saying that object does not emit enough energy. It might be reflecting energy and everything else. And if we don't put that into the calculation, we can have a temperature that's wrong. So watch what happens when I hit enter. It goes from 104.7 to 110. I've got a 6-degree difference just because I have an item that might have a different emissivity. Once I put that number in, it can change the way the temperature is output. This is also important, and I'll come back to me here. So skin, these numbers are scientifically put together to give you an idea of what to put in there to get as close to absolute temperature as you can. So skin is somewhere around 0.97. Just to explain that, I have more energy radiating from my skin than I do bouncing off or it absorbing energy from somewhere else. Whereas something really shiny like my coffee cup here is highly reflective. What the temperature of the actual metal here is hard to know because it's bouncing energy from my hand. It reflects off of it. I've done a number of videos on explaining this a little bit, but that's what happens. I can't get an exact temperature off of this surface because it reflects it way too much, an exact absolute temperature. So radiometry itself, again, becomes a bit more complicated because you have a lot of things that would be in a scene, what we call the observable scene. Let's go back and look at our scene. We have a lot of things in here that might have different emissivity values. So we have to be careful when we're measuring temperature from this same spot and leaving this number, the emissivity number, identical or the same. And let me give you an example of this.
That was one of the things that always stuck with me from the first presentation that you did.
Mhm.
Looking at the image in one spot and the reading from that one spot could be different from the next spot.
Oh, absolutely. And like I said, so here we'll just say I am trying to look at whether the insulators are hot. And if I put my spot meter somewhere on this insulator, and we can see a couple of them in here, right? If I put my spot meter on that insulator and I have basically a temperature showing of 76 degrees, I'll move that. Well, this material happens to be over here on this side of the actual box, or the top of the roof. We would assume, looking at this image, and if I change it to a color palette that's a little bit more, we would assume that this is just cooler. Why would we assume it's cooler rather than it being made of something different that gives us a lower emissivity number to make it look like it's cooler? And that is a huge challenge in radiometry. Because just because of what it's made of, or how it's painted, or if it's rusty, or if it's shiny metal, it can give us a false indication that this spot is a lot cooler than this spot. But if we know what the emissivity of this is, then we can get closer to say, oh, these are probably almost the same identical temperature. And they could be because of their emissivity. I hope that kind of gives you a general idea on that.
I think it does. I did see some questions popping up. I saw
All right, I'm good to answer questions.
there. If you want to unmic yourself and ask a question, feel free to do that.
Mhm.
We have Johnny, you had a couple questions in there if you wanted to open up and ask your questions. And it looks like maybe Zach also answered some of them.
Yeah.
Lorenzo, if you want to go next for a question, that's fine too.
Is that just in the chat window that some people are asking questions? Okay,
Yeah.
Yes.
got it.
And yeah, it looks like Zach actually answered one of mine, because I was thinking about thermal energy and the space between the camera and the subject and how it affects your readouts. Like
A
I'm
lot.
making it like colder, misty days, maybe on borderline of snowing.
Yeah. So there's actually a lot of things. Again, this is it's a really large formula that needs to go into this. And just because we point a thermal camera at something and we see a temperature on the screen doesn't mean it's always right. We have to make sure the settings within that camera, depending on the manufacturer, that those settings can be changed in order for us to get what we call an absolute temperature. Absolute. It can be very complicated. We want to try and stay with emissivity, items that we know that have an emissivity higher than 90, because anything lower than that and the accuracies become very complicated to measure in absolute. So anything higher than 0.90 is much better. So rubber, asphalt, human skin, like I said, things that are not super reflective but can emit their own energy, definitely make it easier to measure an absolute. Additionally, since you're talking about a distance, if we're farther away from something, we have a lot of environment in between that can change the way that formula sees or the camera observes and sees to put absolute. And so I don't usually tell people, well, just because you go to an ITC training and now you know how to use it, an ITC is the thermal training, and get a certification, that just because you did that, you understand theories and understanding, and you can look at things and go, okay, I know as a deliverable, it would be a terrible idea to try to give an absolute temperature on an object that I'm not sure even what that emissivity value is, because you can really make bad decisions on that. Perfectly good to go. There's nothing wrong with it. And then the substation explodes. So because you said it was good to go. So we have to be very, very cautious on that. And it does take a lot of training. It takes a lot of practice, and thermally tuning is what we call it, the thermally tune, to get close. But there are some things where I just say there's like looking at the cow's butt. It's just not going to be a great use case to try and get a temperature from the cow and figure out what cow is sick or not, because we're 100 feet away. So hopefully that answers your questions on distance and environment in between the camera and the subject, which can totally mess with absolute. So.
All right. How about Lorenzo? Would you like to unmute and ask a question? He's got one on there. I'm seeing several popping up here. Okay, I will read it then. What is a good way to do field check of radiometric accuracy? Are there standard temperature sources that can be used to do a quick check in the field?
Okay, so absolutely, there are other ways to measure temperature. And remember, this using a thermal camera is one way to measure absolute temperature. It's one way. But there's other ways. We can actually do a surface contact measurement. For people know what a thermometer is. So, if you wanted to hold a thermometer in your hand, you can get a measurement there. And that's one way to also correctly ground truth something. There's infrared types that, that we would use in the restaurant places, and we point and we get a measurement from there. You're seeing them all over with this COVID thing now of non-contact temperature checking. And you notice that they're not doing it from 200 feet away, right? They're right next to your face. they're getting right up next to you to get that most accurate temperature as close as they can, but no contact. You have to remember that the cameras here are passive. So it's a passive sensor, which means there's nothing emitting from the camera like other sensors. And we're just observing what is coming to us. Just like a normal RGB camera, it only sees what it can see. There's nothing transmitting from the camera and then bouncing back to get a measurement. So got to keep that in mind as well. So there are things to ground truth, is what I'm saying, on making sure that those are pretty close. But again, we have to be very careful. Be very careful. So another question?
All right. Izzy, I don't know if you want to unmute, ask your question. He's got a question about AI.
Sure. Thank you, Desi.
Uh-huh.
Don, just wondering if you think AI can help differentiate with the emissivity in the future. Possibly if you're flying during the day, maybe AI can recognize a tin roof and kind of like rule that out.
I think that's possible, but I don't know if it can do it directly from the imagery. And that's another thing about this next part we'll discuss is mapping. So if you're going directly from an image, and I'll just jump back into our image that we were already observing, looking at here. Jump over. There we go. If we're looking at just the image and the information from the image, Izzy, the AI computer might have a difficulty understanding what's coming in as actual AI, absolute, not the temperature, but more or less the information coming from that single pixel. And it wouldn't be able to go, well, I think it might be a roof, or I think it might be. It would have to look at basically the whole space and area. And AI does do this, for facial recognition and other things. So I think that if you're observing it from, is this a pole? Can the AI identify this as being a pole? And if most poles are wood, but not all pole structures are wood, that's where I can see it being a challenge, if that makes sense. Same thing. It's hard to put in the background that you'd have a whole lot of imagery to kind of use as this is recognizable as a tin roof, but is it tin, or is it shingles, or is it metal? Tin, metal, or galvanized steel, which is a little bit different than tin, right? And could have some different numbers there. Would it be possible? It probably could be. I have a very good friend of mine that's a genius like that does thermal stuff, and he probably figured it out at one point or another. I don't doubt that. In fact, I have a really cool tool that he made for all you H20T users. So it'll be really good. It'll be really good. So, will it help? I hope so. I hope we have AI that can help discern that. When you're looking for people, you're a little bit different out in a big wide field, picking up the little hot spots and deciding that this pixel size is just not large enough to be a person. And that's what's important. We're looking at how many pixels in a space and having an algorithm that can figure that out. I think that would be a really helpful tool, is to discredit hot spots that just are hot, but they're not physically big enough in the pixel density to be an actual physical, to be a person, so.
So with thermography being such a science, what type of training and education do you recommend?
So, well, we'll go back to my own history real fast. So I was building drones for a lot of cinema guys and putting big fancy red cameras. Everyone's a red camera, whatever. We'd put big cameras on big drones and fly them around. And I didn't really have a real desire to understand why the cameras did that, why they were acting the way they were. But when I did put a thermal camera on a drone, I did want to understand why I was seeing what I was seeing and how it was helping or not helping on making decisions out there. Do I see a bad guy? Do I not? Do I see something hot that we should do something about or not? And so when I looked into education, I just jumped all over the internet. But at that time, and maybe this is why, I've become who I've become, is because I really dove deep, because there wasn't a lot of information on aerial thermography. There wasn't a lot of that. Plenty of information on training how to do ground-based inspection. So you have the little handheld cameras, and we take this education from one of those guys, ITC. So it's the Information Training Center. This is hosted or created by FLIR as an arm of FLIR in the education side to get an actual certification in thermography. These come in different levels. So you have level 1 for basic understanding and thermography understanding. Level 2 goes a little bit more in depth in science and understanding and theories. And then 3, definitely program management on doing a lot of high-end work. You also need a level 3 thermographer to teach an ITC class. So even though I've hosted some of the classes to get educated, I don't actually teach them in the higher scientific-y to give you a certification, but we do host ITC classes here at RMUS. So other than breezing the internet, that's really all I had as far as the education back then. And it was interesting to then go to FLIR and be in Santa Barbara with them. And they're asking me all kinds of questions on my experience with this, because they didn't have a lot of it. Do you think, Jon McBride, that a plus or minus 5 degrees C is okay? And here I'm like, I don't even know what that means. 5 C plus or minus, is that important? Well, normally when we're really close, we can get within 0.5 degrees C. But since we're kind of guesstimating on how the UAS camera is going to work, we could be in this range. We don't have as much sensitivities because you're not close to something. I said, well, I would think that was acceptable. But when you have guys that have been educated and know thermography really well, and they have their workflow of doing inspections here, then they go out and do it with a thermal camera from the air. There's a lot of disparity there. There's a lot of problems. So, but you can get educated from the ITC, and that's where I would start. And you're actually getting a certification for that, and that's where you need to be. So.
Awesome. Thank you. Mark, I don't know if you can unmute, but Mark has a question on here. We'll give him a second if he wants to unmute.
Yes, thank you. John, you touched on it a little bit with AI for search and rescue, but for law enforcement purposes, is there any need to tweak any of these emissivity values or whatnot when you're just conducting search and rescue functions, or just leave it as the way it is and hopefully switch to a visual camera when you get a hotspot?
Okay, we'll talk about it. I know Jennifer's here. She's not on my screen right now, but she's gonna be talking about the AUTEL, or Douglas is gonna be talking about the AUTEL next week, it sounds like, for a presentation, but I happen to have one here. the UI, no, we're just going to take the front end off here. So the UI on some of these, what we can consider a search and rescue camera, the app that we use on how we dial in some of how it's presented to us has to be made by the manufacturer to do well. You know, if those things don't exist in there, there's really no advantage to. I mean, there's no way to do it. So that, you know, you just can't. So we just have to kind of work with an image in thermal just coming through the screen. And if the app is capable of fine tuning something to observe a better spot a human out there in the world, then that has to exist in the app. And since we're talking a little bit about the UAS stuff, this guy is not a radiometric camera. So what does that mean? I don't have a lot of ability to tune this for exactly what you're asking. Whereas the XT2 or the H20T, you have the ability to kind of tune these a little bit. Will it help you in identifying a problem or finding somebody? Sometimes it can be, it doesn't at all. As we observed with watching the Fox, it wouldn't have mattered how much I would have changed any emissivity values. It wouldn't have mattered how I would have manipulated the radiometric information. It wouldn't have changed the way it showed up. You know, the Fox would still be hard to see walking across the trail if I only did one image and took one picture. He would still be difficult to see. So it can go both ways, you know, it can go both ways. But as far as most of the public safety guys, they're just, you know, you do your best to try and do training on what does a human look like. And I did do a training, and I'm gonna back up a little bit. I did do a training, and we did thermal trying to find a guy out in the middle of the field. And it's always assumed, I don't know why, that people just die. They die like this. That's how they die. They don't die any other way. This is how they're laying out in the middle of the snow, even when they're trying to be fine and they're not. So when our eyes are going around and looking at stuff, we're looking at somebody that's got their, let's look at things where the legs are sticking out and the arms are sticking out. And if you're actually in public safety, how rare is that? It's pretty rare. What you see is people, you know, doing the cuddled up. So you're looking for balls sometimes of heat. You're not looking for what we would think that we see on the screen of heat. So just something to consider when I've done a lot of training out there. People are like, I think that's a guy. And I'm like, is that how people die? You think that's where they are? That's what happens, is they stay like that, you know, all the time? Very unlikely. So
Too much TV.
too much TV.
Yep.
Too much TV. Yeah. Kim's doing her thing up there.
There
Yep.
you go.
Just decide how you want to look so we can find you, Kim. Just if you go out in the woods and you're like, I remember what John said, likely I'll be found if I stay like this and don't. Yeah.
All right.
Right.
Looks like Johnny had one more question, and then I also have one more up here about, while Johnny gets ready to unmic, about, can you share some of the myths about thermal imaging and the data that you capture?
One more time with that question. I say that
Can
one more
you
time.
share some of the myths that you find regarding capturing images and the thermal images?
I think one of the largest myths is again, largest problems is that when temperature shows up on a screen in real time, that is absolute. We have to be cautious with that. I'll give you a use case. Looking at the top of a building that's on fire. We have firefighters out there and they happen to have a radiometric camera or something like that is giving them temperature popping up through, and they see it on the screen. Well, if they're like, hey, we already know that it would be not good to step on something any higher than 150 degrees, but I'm only showing 95 degrees and they're not near the hot spot. We have to be like I said, we have to be very careful with that, because you can clearly see that it's hot because of the relative hot being hot or cold, but you don't know the observable temperature. So that's another problem that I run into with public safety, going, well, why don't we get a radiometric camera? Because then I can I can see the temperature of something burning, and I can alert my guys to stay away from it. And yeah, you could, but that again can be hard. So that's one myth, is that what you see on the screen is absolute. It is not. We have to bring it into a program in order to get that closest temperature, manipulate it and thermally tune it to get that. So real-time temperature is challenging, super challenging. Another one is that when people map, they take a bunch of JPEG images. JPEG images don't carry any radiometric information in the metadata. So each pixel has a lot more information than just the color. And in photogrammetry and doing video, that's, that little pixel is just a representation of color. Well, we can't see it like that. We have to see it as a representation of radiometric energy. That pixel has metadata in there to have an amount of energy, and we're measuring the energy, or we're trying to stitch together the imagery, that radiometric energy. I'm going to try to open this other image I have here. So let's go to here. So this is a map that was stitched together in thermal using radiometric imagery. And when we actually do, it just looks like a black and white image. But if I bring this into FLIR tools, I'll be able to tune it just like I was doing it earlier. I'd be able to change some things so I can see kind of what's going on in these layers on what they look like. And I'm not looking for absolute temperature. This was flown at about 200 feet high, so it would be hard to get any absolute from this. And when we think that basically we can see, and there's a little bit of moisture right here, and that was one part. There's a little bit of moisture on this one side. If you might have a problem trying to image something like this and then go out and create a map that would show somebody what the water temperatures of the bad factory that's dumping, warm water or sewage into the thing. We can see it from the surface, but we can't see it very well. And when we can't see it underneath, and again, we're only talking surface level information from water. But when I stitch together here, I have to make sure that all of my radiometric information retains it. Otherwise, we can get, again, some problems that arise in the stitch itself. I wish I had a bad example, but this is a good example of stitching something. Let me see. Seeing if I can find a bad example, but I don't know if I have one. Of where you have one image that looks really good, and then the next image it looks terrible, but when you stitch them together, the colors are good, but they don't represent correctly, So even when we stitch stuff, we have some averaging of those pixels, averaging of the color. It's not the absolute color from the one image. And when we do that, that can be another myth or problem of just stitch them in JPEG, you'll be fine. That's not good to do. It's a bad one. So like I said, Desi, I could go on all day about this stuff, just letting you know. I do have my coffee.
Well, we are coming up on the end of our time. And so the one big takeaway is it takes training. And you don't just go out there, throw a drone in the air and think you're going to get quality data. You need to get that training. And so we cannot thank you enough. Oh my gosh, it was so fantastic. Everybody has all these questions coming in, and I know we would be taking up a lot more of your time. I did put your information to RMUS into the chat. So if anybody wanted to share that or save that, they can, but I didn't put your email if you wanted to put contact information or anything or share that with anybody. We can put that in there.
Yeah, if you have any direct questions to me concerning any thermal or anything like that, there's my email.
Awesome. Awesome.
But any sales inquiries or tech questions, that kind of go through or flow through RMUS, you got the right email there.
Jon, thank you so much. You are just such a wealth of information. We can't.
I have way too much, Desi, way too much information. And like I said, this is these when I go to the shows and I'm part of the things these are these side conversations you have pretty much the whole rest of the time of how it works and what it is and how I do stuff. So hopefully this was helpful in your audience of just kind of a general information. There is so much to learn in thermal and so much to do and try to understand that it takes a little bit more than a brief 1 hour show. But I really wanted to say thank you for you two to have me on here and present it and get some information out there. So thank you so much.
That kind of wraps it up.